Hello, welcome back to the channel. So let's move on to a new topic which is about sequence and series. So in this video and in the upcoming videos as well, we'll cover some basic concepts about sequences, and then we'll use all the concepts about sequences in order to do questions which are based on series. So now let's first define what a sequence is. A sequence is basically a list of infinitely many numbers which have a specified order, which have a specified pattern. Let's suppose we have a list of infinitely many ones in there. So you have a list of infinitely many ones over here, right? So this is also a sequence because the numbers have a specified order, the numbers have a specified pattern, which is basically if you add plus 0 to every term, you'll get the next term, right? And it's an infinite sequence as well. So that is what exactly a sequence is. A sequence is basically a list of infinitely many numbers which have a specified order, which have a specified pattern, for which you can represent your nth term with a numerical formula. So for example, let's take the example of three sequences over here. So you can see that the first sequence is 1, 1 by 2, 1 by 3. So you can clearly notice that the nth term is 1 by n because the first term is 1 by 1, the second term is 1 by 2. So the nth term is 1 by n. And you can notice over here as well that you can represent your nth term in a specified order in a specified numerical formula, right? So whenever this happens, you can call your list of numbers as a sequence. The condition is they have to be infinitely many numbers. And the second condition is basically you should be able to represent your nth term in a numerical formula over here. And then the second sequence is basically the sequence of natural numbers. So your nth term is n. The last sequence is alternating sequence of 1 and minus 1. So 1 minus 1, 1 minus 1. And then you can also represent your sequence, your nth term with this formula over here, right? You can clearly notice that you can solve for your first term by substituting n equals 1. If you substitute n equals 1, you get minus 1 to the power 0, which is 1. If you substitute n equals 2 to get the second term, you have minus 1 to the power 1, which is minus 1. And then you can keep on repeating the same process to generate this sequence over here, right? So now we have a basic idea about what a sequence is. The main thing that we are concerned about sequences is to check whether these sequences converge or diverge, whether the sequence that you are writing, whether the sequence that you have has a definite end or not. And the way to solve this is if you want to prove that a sequence converges, you calculate your nth term expression. So you calculate an expression for your nth term, and then you take limit n approaches to infinity for that nth term. And if that limit of n approaches to infinity for your nth term converges to a real value, has a real solution, if this limit has a real solution, then you can clearly say that your sequence will converge. So basically a sequence is said to converge if it also converges, if the nth term also converges to some limit. Otherwise, you can say that your sequence will diverge. So if your limit does not exist, if the limit for this expression does not exist, your sequence will diverge. And this makes sense as well, right? If you keep on adding the following numbers in your sequence until the numbers approach infinity, and you also know that the last term has a real solution, the last term would be a real value, then you can clearly say that the sequence will converge, right? And that is what this theorem is all about. So we can take one example over here. We have to calculate whether this sequence whose nth term is n upon n plus 1, we have to calculate n upon 2n plus 1. We have to check whether the sequence which is formed by this expression over here converges or diverges. So we'll use the same concept in order to check whether a sequence converges or diverges. When we have been given the nth term, we have to just calculate the limit for n tending to infinity of a of n, right? This is basically checking the behavior of our sequence when our n will approach to infinity, right? And if this gives us a real solution, this gives us a real value, then we can clearly say that our sequence will converge, right? So let's calculate this expression over here. If we have to calculate this expression, it will be basically limit n tending to infinity, n upon 2n plus 1. So now you can clearly notice that you have an infinity by infinity term over here. So the method in order to solve these type of expressions is we factor out the highest degree polynomial from the numerator and also from the denominator. So since the highest degree polynomial in this case, the highest degree polynomial term in this case is n, so we'll have to factor out n from the numerator and also n from the denominator. And if we do that, it will basically be limit n tending to infinity n times 1 upon, if we take n common in the denominator, it will be basically 2 plus 1 by n in this case. And now we can cancel these n's such that we will have only limit n tending to infinity for 1 upon 2 plus 1 by n in this case, right? And now you know that when you take limit of n tending to infinity of 1 by n, you know that it's 0. So we already know that limit n tending to infinity for 1 by n is 0. So if we take the limit of this expression over here, we will get 1 over 2 plus 0, which is 1 over 2 in this case, right? So now you can clearly notice that your limit for n tending to infinity of a of n is 1 by 2, which is a real value, right? So now, since this is a real value, you can clearly say that your sequence, whose nth term is denoted by this expression over here, will converge, and it will converge to 1 by 2 in this case, which you can clearly notice in the solution to this answer over here as well, right? So that's it for this video. Again, the main takeaway from this video is to check whether your sequence converges or diverges. So this is one way of checking whether your sequence converges or diverges. We'll cover some other ways as well, which you can use in order to check whether your sequence converges or diverges. And we are basically doing this in order to build those concepts that we will be using to check whether our series, the series that we'll cover in the next videos, will diverge or converge. So now we are learning about sequences, but we'll use all the concepts that we'll learn in sequences and apply it to the series problems. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.